Hello everyone. Today we will continue with our topic gravitation. So first of all, today we will see the difference between the symbol capital G and small g. In the previous videos we have studied about them. So what is capital G? The symbol capital G, it is the universal gravitational constant, and small g is the acceleration due to gravity. The value of g is 6.67 into 10 to the power minus 11 Newton meter square per kg square, and the value of small g is approximately 9.8 meter per second square, and the value of g varies from one place to another on earth. Also constant throughout the universe. The value of g is constant throughout the universe. Changes from every place to place. Example, on the moon the value of g is 1/6 that on the earth's surface. About this we will learn in our next slides. So first of all, for the topic for today's video is mass. Now what is mass? It is the amount of matter present in any body or anything. It always remains constant and it does not depend on the gravity. Here in the picture you can see that the amount of matter in an object measure is always measured in grams, and a bowling ball compared to a beach ball is much heavier, therefore it has more mass. Now you can see here a bowling ball. Now you know that a bowling ball is much heavier than any other ball. Why? Because it has much mass, more mass than other balls. Now, what is weight? It is a body's relative mass or the quantity of matter contained by it, giving rise to downward force and the heaviness of a person or a thing. Now let's see how we will calculate the weight of any body. We know that F is equals to ma, and here m is the mass of an object, and we will here replace a with g, and g is the acceleration due to gravity. Here a was to a particular thing and here it is to a particular body. So the force of attraction of the earth on an object is known as the weight of the object. It is denoted by W. Now substituting this W in equation 2, we will get W is equals to mg. Now this is the weight of any object or a person. As the weight of an object is the force with which it is attracted towards the earth, the SI unit of weight is the same as that of the force, that is Newton. The weight of is the force acting vertically downwards, that is we are always attracted towards the earth, so the force acts vertically downwards. It has both magnitude and direction. Now the mass versus weight. Now mass of an object will be the same no matter wherever the object is located, and weight of an object will vary according to the gravitational force experienced by the object. In the previous slide we learned that the weight is the scalar product of mass and acceleration due to gravity. It contains two things, and the gravity of an object, the gravity force of any place would change, so the weight of an object will vary from place to place, and the mass will remain the same because our mass or any object's mass will always remain the same. Now how we will measure mass and weight? To measure the mass we use electronic balance, and to measure the weight we use Newton meter spring balance to measure the object. Now difference between mass and weight. Mass of a body remains constant, and the weight of a body can change from place to place because the acceleration due to gravity changes from place to place. Mass of body is never zero, because if mass becomes zero, then weight of body also becomes zero, but it can never be zero. Also, weight of a body at the center of the earth is zero because the gravitational force would be zero. So the weight of the mass of body into zero would be equal to zero. Mass is a scalar quantity because it contains only one term, while weight is a vector quantity because it contains the multiplication of two quantities. Mass is measured in kilogram. Weight is measured in kilowatt or Newton. Mass is measured by a beam balance. Weight is measured by a weighing machine or a spring balance. Weight of an object on the moon. On the moon, here you can see two people, Neil and Buzz. Now, Buzz says to Niels, Neil, I have lost so much mass since coming to space. Now, friends, is this possible? No, because the mass remains same. The weight changes because the mass of a body always remains constant. Here weight changes because the acceleration due to gravity of the moon changes. So its pull towards the moon changes. It is lesser. So we have lesser weight on the moon. The mass of moon is 1 by 100 times and its radius is 1 by 4 times that of the earth. So as a result, the gravitational attraction on the moon is about 1/6. Let's see how this 1 by 6 come. Weight of an object on a moon. Let the mass of an object be m and let its weight be Wm on the moon. So we have taken here Wm weight with respect to moon. Let the mass of the moon be mm, that is mass, and with respect to m, that is moon, and its radius be rm, that is radius of moon compared with of the moon. By applying the universal law of gravitation, the weight of the object on the moon will become Wm, weight of moon, is equals to gravitational constant into mm, that is mass of the moon, into m, that is mass of the object, upon the distance between both the object and the moon and its square. So this would be the Wm. Now let the weight of the same object on the earth be We. Now here we had taken Wm, now here we consider We, that is the weight of the earth. The mass of the earth is m and its radius be r. So from equation 1 and W is equals to mg, we get W is equals to g m into m upon r square. Now here we are given some values: mass of earth and its radius, and mass of moon and its radius. Now substituting these values in equation 1 and 2, we will get weight of moon as g into the value 7.36 into 10 to the power 22 kg into m. That is, we have kept the value of object as m only, and we have not substituted any value for m. And its radius is 1.74 into 10 to the power 6 meters. So we get the value of Wm as 2.431 into 10 to the power 10 gm. Here g is the gravitational constant. And similarly, we get the weight of earth as 1.474 into 10 to the power 11 gm, where g is the gravitational constant. So now by 3a and 3b, we divide 3a by 3b. So we get Wm upon We, that is weight of moon upon weight of earth, is equals to the values. So 2.431 into 10 to the power 10 divided by 1.474 into 10 to the power 11. We get 1 by approximately 0.165, which is equal to 1 by 6. So we can say that weight of the object on moon is equal to 1 by 6 the weight of the earth. So now you can understand that why in the first slide 1 by 6 was there. Now let's see example 10.4. Mass of an object is 10 kilogram. What is its weight on earth? So we know that mass is 10 kg. Acceleration due to gravity is 9.8 meter per second square. So W is equals to mg. So we get W is equals to 10 into 9.8 meter per second square, which is equals to 98 Newton. That was our mass was given and we had to find weight. So W is equals to m into g. So we got 98 Newton. Thus the weight of an object is 98. Now example 10.5. An object weighs 10 Newton when measured on the surface of the earth. what would be its weight when measured on the surface of the moon? So let's see solution. We know that weight of an object on the moon is equals to 1/6 its weight on the earth. Now substituting the values, you will get Wm is equals to We, that is weight of moon is equals to weight of earth divided by 6, and we are given the weight of moon is 10 Newton. So 10 by 6, which gives 1.67 Newton. So the weight of an object on the surface of the moon would be 1.67 Newton when its weight on the surface of the earth was 10 Newton. Thank you, and if you have any doubt, comment in the comment section.